Okay, we're going to be learning about a library class called HashSet. So I've got a HashSet here. We're not going to actually look at the code in the library, but we're going to learn about how it could be implemented. And we're going to learn about two ways. One is chaining and one is open addressing. But first, I want to make sure that you have the idea of a set in general. So a set is going to keep a collection of things and it's not going to store any duplicates. So if I start off here and I just print the size of my set, my size is going to be 0, perhaps not surprising. So now say I want to add something to my set, I could add zebra to my set. And now I should find that my size is 1. Okay, so it just has one element in it. But what if I add zebra 3 times? The important thing about a set is it's not going to keep duplicate, so I should still just have a size of 1. And you can imagine if I remove zebra, then I'm going to get back down to a size of 0. One more method that I want to show you is that I can call contains. So I can check, does it contain the string zebra? And here I need to print that because otherwise I won't see anything. So you can see I've removed it, so my set.contain zebra is false, and then size is 0. So this is important background so that we can learn about two ways of implementing a hash set. One is chaining and the other is open addressing. Okay, we're going to trace through the code that I have here twice. One's for chaining and one's for open addressing. So let's just walk through it. I've got my set, which is a hash set containing strings, and then I'm going to call add a bunch of times, and I'm going to call contains and remove. So I add tiger, I check if it contains tiger, I add panda, I try and add panda again, that won't add a duplicate item. I try and add zebra, I add giraffe, I add bear, lion, camel, I check if it contains camel, and then I'll remove lion. So we'll trace through this twice. And the reason we're tracing through this is to try and understand how methods like add and contains and remove are going to be really similar, but how methods like add actually work. Again, we're not going to look at the source code, but we're going to explain these two methods, chaining and open addressing. Both of those methods are going to rely on some key infrastructure. Whenever we call add, we're going to take the item that we're adding and we're going to call a method named hashcode on it. That'll happen every time. And sometimes we're going to take that item and call .equals on it with another item that's already in the hash set. So when we're thinking about how to implement add or what our choices might be, the key thing is that we need to figure out a reliable way for where we're going to store that so that we can find it later on. And you can imagine just doing this in a list and then you can search through that list to try and find it again. But both of these, chaining and open addressing, are going to implement a strategy where we want to have a reliable way of knowing where we would put it so we can jump right to the spot where we should have put it.
And in practice,
that's going to get us O of 1 or sort of constant time access to be able to add, check if something is in there using contains, or to remove something. Okay, to implement that reliable way of knowing where we would put something, we're going to use that method I mentioned called hashcode. Let's look at that. Okay, so now we're zooming in on that hashcode method. You can see that I set s to tiger, and then I'm going to call s.hashcode. And that's going to give us a number.
And in a single execution, no matter how many times I call hashcode,
I always get the same number. That is super important. Depending upon what version number of Java you're using, you might get a different number, but it will always be reliable. It'll always be consistent. And we can imagine writing our own hashcode method. We just have to make sure that for the same object, hashcode will always return the same value. So for a string, you can imagine that hashcode could just return the length of the string. We could be certain that for the same object, hashcode would always return the same value. For convenience, let's print out the hashcode of all of the strings that we're going to use in that example main method that we're running. So here I have tiger, panda, zebra, giraffe, bear, lion, and camel. That's what we need. And when I run it, it will give me the hashcode of each of those. And again, that hash code for each of those strings is always going to be consistent. Okay, now we're ready to trace through the code. Both chaining and open addressing are going to use an underlying data structure of an array. And it's super important to remember that we can access an element in an array in constant time. So if we want the 99th element. We don't have to walk through each of the previous elements. We can jump right to the spot. We can jump right to an index in constant time. That's one of the important properties of arrays that we're going to build on here. Okay, now let's dive into how we do chaining.